Hey there, it's Code SB with yet another AI voice. Let's learn how the vector container works in C++ or any other programming language. They may call it something else, but essentially, it's all the same. Let's first see what it really is. If you already know, feel free to skip to the later part where I'll explain the working. It consists of the following properties: initially zero-sized, variable size, grow as required, and heap allocated. You see an asterisk with the initially zero property, and that's because some implementations don't have it initially zero, but instead they start with a capacity of 2, more on capacity later. Variable size means that, well, it adjusts its size as required. Heap allocated means that, do I even have to explain that one? The next thing is that it's implemented as a class, which means that it can have methods, constructors, destructors, and we can make it generic to have any type that we want. And by now, you may have noticed that in order to understand how it works, you're going to have to know the basic concepts of programming like heap allocations, arrays, classes, etc. For a better understanding, we will start our array that has the capacity of 2. Have a good clarification on these two boys, size and capacity. Size is how many indexed we've used in the array, and capacity is how many elements the array can hold. That being said, our array has the capacity of 2 and size 0. We push some data in there and the size becomes 1. Push some more data and now the size is also 2. At this point, our array cannot accommodate any more elements. It has to be readjusted. So that's what it'll do, by doubling its capacity. Now this is also different. Some compilers do it 1.5 times while others double it. We'll go with doubling the previous capacity or size because at this point, both capacity and size are equal, so it wouldn't make a difference which variable we use to double the capacity. Doing that will make the capacity, which was previously 2, now 4. And that's how many elements it's going to be able to hold now. The next step is to copy the old array into the starting indexes of the newly allocated array. The animation just moved it over there, but the old array is still going to be floating over there in memory. So our perfectly managed vector class will call the destructor for the old array before moving on, because we don't want memory suing us. We done with that poop. Anyway, now we have more space for more data. It will be able to allow more data to be pushed until the size and the capacity become equal once. Again, at that point, the same reallocation, copying, and deallocation process is going to repeat. And this is how it's never going to complain. Hey bruh, we outta indexes here. I'm gonna die now. That is now the vector class's headache, and that's how the vector, dynamic array, list array, or whatever you may want to call it, works. I hope that it's clear to you now the whole process. If it helped you, please make sure that you help me back by subscribing, liking, commenting, sharing, and everything. I know it's a lot to ask, that's why I asked you. That's it for this video, and I will see you in another one.